Welcome to the podcast. Today, we're diving into this ultra advanced unified power platform that changes how we think about energy storage and delivery. It's basically built on a dual megamp architecture paired with a super hybrid capacitor.
Yep. Right, so we're talking about decoupling power generation from immediate load demand, which means energy storage is separate from the generation process. What's the neat part about that?
Well, it creates a perfectly buffered system. The design uses two magnetic amplifiers, one on the charging side and one on the discharging side. To ensure power flows smoothly, it allows for a
True.
continuous, self-optimizing energy flow, whether you're powering a house or even a national grid.
That's impressive. And the superhybrid capacitor? How does that differ from typical batteries or regular capacitors?
The super hybrid capacitor is really a game changer. It's an AC-only component that uses a low-pressure plasma in a superhybrid gas environment, like Xenon or Argon, which makes it immune to the cycle-based wear you'd see in lithium-ion batteries. It offers near-infinite lifespan and doesn't need any maintenance.
So, essentially, instead of constantly recharging state-of-the-art lithium-ion systems that slowly degrade, this platform promises install and forget, which is huge for cost and efficiency in long-term applications.
Exactly, and it's not just for one field. The paper details application across 5 key sectors: grid and residential, automotive, marine, data centers, and aerospace. It's like a universal solution, scalable from kilowatts to gigawatts.
Yeah, I remember they mentioned how grid applications can use it as a distributed power buffer that flattens the load curve, right?
Right, take a home or even a factory. The system continuously draws a low, steady charge from the grid, and then, boom, when a high load appliance kicks in, the output megamp discharges instantly, smoothing out the power demand. No more huge spikes that force utilities to run inefficient peaker plants.
That's really strategic. But what about the automotive sector? Electric vehicles have been struggling with consistent performance in cold weather.
Exactly. In EVs, the super hybrid capacitor module works alongside the main battery, kind of like a performance booster. During events like regenerative braking, it captures that energy rapidly and then gives an instant surge when needed for acceleration,
Right.
significantly extending the range and performance even in colder climates.
It seems almost like having a turbo for your car, but for electrical energy. It's a neat trick to offload high power bursts, right?
Yes, yep. It essentially reduces strain on the main battery, ensuring the vehicle operates efficiently. And the fact that it helps manage high-power charging events means it could alleviate the need for expensive, high-voltage charging infrastructure entirely.
I love that idea. But what about the marine applications? Propulsion has always been such a maintenance nightmare with traditional systems.
Right, in marine settings, the platform powers linear water jet drives rather than traditional propellers. This modular carbon fiber-based design not only lowers maintenance by eliminating long dry docking periods, but it also cuts noise and, interestingly, drastically improves maneuverability.
That's very cool. So instead of relying on spinning propellers that can be heavy and inefficient, you get a system which is lightweight and can instantly reverse thrust.
Precisely. And there's no need to constantly access the grid's peak power because the capacitor can hold a burst of energy ready for when it's most needed. It's a perfect solution for cost saving and performance enhancement.
Switching gears a bit, data centers really benefit from reliability. How does the system work there?
Data centers currently depend on batteries that have all sorts of issues: short lifespan, cooling requirements, and fire risk. This system, with its battery-free UPS setup using these plasma capacitors, offers near-perfect power conditioning. It means zero maintenance and a constant supply regardless of grid fluctuations. Plus, it removes the need
MHM?
for a bulky battery room.
And when it comes to aerospace, the application becomes even more fascinating. An ion drive afterburner, right?
Right, space applications are revolutionized by this approach. By decoupling power generation from delivery, a spacecraft can slowly charge these capacitors using something like a solar array or an RTG. And when you need that quick burst for a maneuver, zap, you get that millisecond level surge. It dramatically improves mission-critical maneuvers like orbital insertion or even high-speed transit.
You know, one point that might need challenging is the claim of near infinite lifespan. While the capacitor might not degrade, isn't the longevity of the system still somewhat tied to the supporting structures or the control circuitry?
That's a fair critique. While the core capacitor itself offers exceptional durability, the overall system's lifespan would still depend on the integrity of the control circuits and the maintenance of the peripheral components. However, the design does aim to seal everything in an injection-molded carbon fiber composite casing, which is meant to be extremely durable,
Yes, exactly.
though real-world long-term testing will tell the ultimate story.
And speaking of control circuits, I noticed they use dual magnetic amplifiers, one for charging and one for discharging. It seems critical for the system to both isolate the grid fluctuations and to deliver instantaneous power. Isn't that almost like having two dedicated traffic controllers managing incoming and outgoing flows?
Exactly. It's like having two separate maestros ensuring the energy symphony is perfectly in rhythm. The input side magamp conditions the power, turning variable inputs into a smooth charge, while the output side magamp instantly discharges based on demand. That separation is key to avoiding losses and inefficiencies.
I also saw that the system has been detailed for high-frequency propulsion systems for naval and even aircraft carrier applications. How do those applications tie in with what we've been exploring?
That's a whole other layer. Here, the system is adapted to replace bulky, heavy, conventional propulsion systems with a lightweight, high-frequency drive controlled by magamps that operate at up to 100 kilohertz. In naval applications, the weight savings can be in the order of 1,000 tons, which translates to not only fuel efficiency, but also enhanced maneuverability and tactical advantage, especially in a modern combat environment.
And for something like an aircraft carrier, even a relatively small weight saving compared to the overall displacement can free up space for additional fuel or armaments, right?
Exactly. It can be reallocated to enhance stability or increase payload capacity. The distributed nature of the electric drive means you can significantly reduce the single point of failure, the central mechanical drivetrain, and instead have a robust, dispersed system with redundancy built in. It's a major strategic shift in naval design.
Let's also touch on the financial projections briefly. The business plan includes a detailed cost model for a domestic 15 kilowatt-hour system, scaling up from grid applications to high-end data centers and even aerospace. What stands out to you there?
The really compelling part of the financials is that despite an initial system cost in the range of a few $1,000s, the total cost of ownership remains extremely low. That's because you're avoiding those recurring maintenance and replacement costs associated with conventional batteries and generators. This is truly an install and forget model, and when you factor in long-term savings in, say, reduced downtime and improved performance, the ROI becomes very attractive.
Absolutely. And the cost tables also compare this system with lithium-ion batteries and diesel generators, showing drastic savings over the life cycle. It really flips the traditional just-in-time model on its head, moving towards a power-on-demand approach rather than an always overbuilt grid.
Right on. It's designed to smoothly integrate intermittent renewable sources with a decoupled, buffered system, which is crucial for our energy future.
Indeed.
This could be the cornerstone of a sustainable, distributed energy infrastructure.
Now, one interesting aspect we haven't touched on is the system's modularity. It's scalable and adaptable to many sectors. Can you elaborate on how that's achieved?
Sure, the whole platform is modular because you're using scalable components, both the capacitor and the magamps. You can tailor a system for everything from a small residential backup to a massive 30 megawatt data center, or even a high-performance propulsion system on a warship. Basically, as you scale up, you benefit from economies of scale which lower per kilowatt-hour costs, and the fixed, durable nature of the components makes it highly adaptable. The same fundamental technology can be reconfigured based on power requirements.
I appreciate that adaptability. But I have to ask, Are there any real-world limitations we might face when transitioning from this theoretical platform to mass production?
Well, scaling up from prototypes to mass production always brings challenges. Material sourcing, ensuring uniform quality in the injection molded casings, and maintaining the ultra-high efficiency of the magamps at scale are non-trivial. However, the design purposely uses robust, well-understood materials like carbon fiber composites and relies on solid-state components that already exist in various
That makes
forms,
sense.
though further prototyping and testing will definitely be crucial.
Totally agree. And the business plan even includes phased market entry, from early adopters in aerospace and data centers to later expansion into residential and maritime sectors. That phased strategy seems smart, given the diverse challenges in each area.
Exactly. It's a staged roadmap. It allows them to fine-tune the technology and financial models at each step before targeting mass markets. That strategic approach minimizes risk while maximizing potential returns.
To wrap things up, the Unified Power Platform really seems positioned to redefine power management across multiple sectors by offering reliability, rapid response, and incredibly low long-term costs. It's exciting to think about how it might change our daily lives and even our approach to large-scale energy and propulsion systems.
Definitely, and it's this kind of cross-industry innovation that could be a real game changer, not just for energy, but for transportation, data, and defense. Thanks for this
Absolutely.
deep dive today.
Thank you as well. I'm looking forward to seeing how this technology evolves and impacts our future.